Hello again, my students. I'm going to continue the study of charging of a capacitor. Remember, in the last video, we applied the law of addition of voltage to get the differential equation. And from this differential equation, going to mathematics, we obtain the solution of this equation. Here it is. Here is the solution. Okay? And what is Q? Q equal CE, which is similar to Q equal Cu, the basic rule. Okay? This is the maximum charge on the capacitor. This is the charge at any instant of time. And what is tau? Tau equal RC, called time constant of the circuit. Why is time constant? Let's study the dimensional analysis. Check the units. This is tau. Dimensional analysis, I mean studying the unit of tau. Tau equal RC. What is the unit of R? Ohms, right? This is ohms times C, capacitance of the capacitor. What is the unit of the capacitance? Farad, right? So equal. But what is ohms? What is ohms? It is U over I, means volt over ampere, right? Times. What is farad? Farad is Q over U, right? Means coulomb over volt. Now cancel volt with volt. What do you get? You get coulomb over what? Over ampere. But coulomb over ampere, which is the dimension of Q over time, over I, sorry, ampere. Charge over current equal time, which is second. Right? So what is the unit of tau? The unit of tau is second. Okay? Good. So let's continue. I'm going to continue with an important remark. But before I do the remark, let me obtain first the voltage U equal Q over C, right? And this is equal to Q over C into 1 minus exponential minus T over tau. But Q over C, let's check it here. Q over C, this is Q equal what? Here is it. This Q equal CE. So Q over C is E. So this is what? This is E. In this case, you get the voltage across the capacitor as a function of time. U across the capacitor, which is U and B, equal E into 1 minus E to the minus D over tau. Now the question is that, do you have to recognize this solution or the above solution? No, not necessary. You do not have to recognize this solution. It is always given in the exam, okay? But here, just to show you that the function is an exponential function. E is called exponential function in mathematics. Now let's get the electric current. I, electric current in the circuit, I equal Let's go back to the expression of the current. It is what? The current I equal Q prime, the derivative of the charge, right? So I equal Q prime. Okay, nice. Equal, where is Q? Here is Q. Q minus Q exponential minus T over tau, and all of this prime, right? Okay, good. Now let's do the derivative. What is the derivative of Q? 0, yes, because Q is constant. The derivative of a constant is 0, so this is 0. Minus, this is minus. What is the derivative of Q exponential? Q is constant. Here's Q. And derivative of exponential e power u is u prime e power u. So minus times minus plus e over tau exponential minus t over tau. Okay? Let me show this in detail, the derivative. You could have studied the derivative in mathematics of the exponential. You could have not studied the derivative. Okay? So let me show you in detail this derivative. In math, write it here. In math, if you have a function y equal a exponential, sorry, exponential u, where u is a function, u of x here. This is u of x. Now y prime, that's the rule. A is a multiplicative constant, it remains. E power u, now u prime e power u, that's the rule. Okay, so and so if we try to make the derivative of our function, my function is, I mean the exponential part of the function, minus q e power minus t over tau. So this is u, this is u. If you do the derivative, p is the variable and tau is constant. So notice here, u prime is equal derivative of time t1. So minus 1 over tau. Clear? This is u prime. So put u prime here and a is minus q. Then you get q over tau exponential. Okay? So our function, the current I equal q over tau. Right? So I turn into black. I equal q over tau. But q is what? CE. And what? And this is what? RC tau. Exponential minus t over tau. Right? So cancel C with C. What do you get? We get I equal E over R exponential minus T over tau. This is the expression of the electric current. Of course, you don't have to recognize this expression, but we want to use it in our analysis. Okay? Now we study an important remark. Important remark. Notice here, first remark, at t equal to 0 for time 0, let's find the charge. Charge on the capacitor is, go back to this equation here, replace time 0. Exponential power 0 is what? 0, right? Exponential power 0, 1. So 1 minus 1, 0. Q times 0, 0. Okay? So at equal to 0, this is equal Q into 1 minus e power 0, 1. This is equal to 0. And that's true. Also, the voltage across the capacitor at equal to 0, because Q equals Cu is 0. And the electric current I, let's find I. And I equal, here's I, e power 0, 1. So I equal E over R. And please let me write it here like this. Better for you. This is I, electric current, at equal to 0. Call it I0. Clear? E over R. And notice this is maximum value, maximum current, because this is a maximum voltage. So at equal to 0, the capacitor is neutral. This is true. Look here, Q equal 0. And the voltage is 0 across the capacitor. But the current is maximum current. Okay? So let's do at equal now tau, the time constant, at t equal tau. 1 tau, replace, you get, let me call it Q1 equal Q, replace in the function of course, 1 minus e power minus t over tau means tau over tau is 1. So power minus 1, okay? If you do this calculation, what do you get? We get Q1, which is the time at equal 1 tau, 0.63 Q equal, if you write it in percentage, 63% of Q. So the capacitor charges up to 63% after a time interval equals 1 tau. So after 1 tau, the capacitor charges up to 63%. And let's calculate the current. I equal E over R e power minus 1. If you do the calculation, you get 0.37 I0. You know the meaning of I0. E over R, right? This is I0. Clear? It means 37% of I0, right? So the current drops by 63% because the remaining part is 37%. Okay? I continue.